So in this question, a man drives a distance of 3.25 kilometers north, then a distance of 5 kilometers west, and a distance of 1.5 kilometers south. What is the magnitude of the resultant vector? So the first thing you do is just draw a picture. So you have 3.25 kilometers north, 5 kilometers west, and 1.55 kilometers south. And all I did was label it A, B, and C, just to make it easier. So the question says, what is the magnitude of the resultant vector? So the resultant vector means that we're going to add up all these. And I said the resultant vector's name will be D. So ABC will add up to BD. So the magnitude is length. So we know we can predict that the answer will be positive because magnitude is a length, meaning if it's like 1 mile, it has to be positive. It can't be negative 1 miles. And since the units will be kilometers, so we know the answer will be in kilometers. Or whatever they specify. But since they didn't specify, it'll still be in kilometers. Always predict that. Always try to predict your answer, so therefore it'll prevent careless mistakes. So to do vector addition, what you do is you separate it into the x and y components for D. This helps ensure accuracy, so you know exactly how much force is in the x direction and y direction. Therefore, you can calculate how much force the distance of D. So now what we do is we're just going to go through how to get each of these. So AX, the x component of A. Since A is completely on the y-axis, there's no part of it on the x-axis. Meaning if I was plotting a point, it would all be on the y-axis. Nothing would be, I wouldn't have to go right on the x-axis or left on the x-axis and then go up. It's just completely on the y-axis. Because of that, it's going to be 0, because there's no part on the x. So the next one is B. For B, it's completely the opposite, meaning it's completely on the x-axis. Now you have to pay attention to what part of the x-axis you're on. Since these two parts are negative and you're on this part, this will be -5. And then the final one, CX, the x component of C, once again, it's completely on the y-axis. So there's no part of it on the x-axis. So since it's completely on the y-axis, it'll be 0 because there's no x component. Moving on to the y component of D. So here we have A, B, and C. So starting from A, once again, it's completely on the y-axis, meaning since no part of it is on the x-axis, all of it will be the y component. So it'll be 3.25. The B, since it's completely on the x-axis, no part is on the y, it'll just be 0. And then next, C, the y component of C. Since it's completely on the y-axis, and it's on the negative part of the y-axis, it's going to be -1.55. So this becomes important because these two, once you add these, you'll get 1.7. And here it's just -5. Okay, since we have the x component of D and the y component of D, now we need to find the actual vector D. So what you do is you just draw what it looks like. So if we know the x component is -5, that means we go -5 on here, right? So it'll be on this side. And here it's 1.7, so on the graph we go up 1.7. So this is what it looks like. And so the vector has to be in the middle. Is the vector, like if you pull it apart, it becomes the x and y. But if you combine it, it becomes here. So it'll be in the second quadrant. Okay, so now we can solve for the length of this, because now we have the sides. So I went down, and all I do here is I move this and shift it here. So therefore it looks like a triangle. And now, since this side was 1.7, and up here it's -5, all I do is, now it's just a simple Pythagorean theorem problem. To find, because the magnitude is the length, and we have each of the vectors, and the vectors are lengths, so we're finding the third side. So the Pythagorean theorem formula is a squared plus b squared equals c squared. So all you do is -5 squared, 1.7 squared equals c squared, square root all of that, and you get 5.28, but we're not done yet because in the beginning I said that the units will be kilometers, so we have 5.28 kilometers, and that will be the answer. Here, don't confuse this with the name. Even though the name of it's still the resultant vector d, the c is just from the Pythagorean theorem formula. So that's the answer, and let's just check to make sure we answer the question. So it asked for the magnitude. That's what we have. We have a length in kilometers, and of the resultant vector, that's what we calculated, and we have the right units of kilometers, and even sig figs, because it's 3 sig figs. So we have everything required, and we're good. So that the final answer will be 5.28 kilometers. I hope that helped, and thanks for watching.